If I remember correctly, in the last class, we completed up to the gate bit of T-mod registers. That means we have covered T-mod register, T-con register, and timer 1 and timer 0 registers, but we still don't know how to actually create delays using these timers, right?
স্যার একটু জোরে বললে ভালো হয়।
হ্যাঁ, কথা শোনাচ্ছে না? Is it equal for all of you?
স্যার শোনা যাচ্ছে স্যার।
All right. I mean, if it is not clear, you can let me know. Then I have to change the earphone or something. Okay? So today we'll start with codes and examples. Okay? Before that, we need to know how to do the code. I mean, in different modes. Let us begin with mode 1. Let me know when I finish writing. I think this thing is directly there in your book also. Can I continue? Yes, no, say something.
Yes sir.
I will explain all these things with the example, okay? Over here, I will not explain anything. I will come back to this page time and again to explain. So let's take an example. All right, now this is the code. Let us just analyze the code. Okay. Let me get back. The first one says that load tmod register with the desired value. As you can see, we have loaded tmod with 0, 1. So if this is your tmod register, 8-bit, as you can see, tell me what are the values in this tmod register, starting from the MSB. Tell me what are the values.
0, 0, 0, 0, 1. And
0, 0,
1 will be at the end. I mean, so
1
let's
will
see.
be at the end. So this is the value that we load with the first line. If this is the case, in tmod, there are a lot of informations that we get. The first question is, tell me which timer are we using from this tmod register, from seeing this tmod, which timer do you think we are using?
So timer 0.
See, again, it can be timer 0 or timer 1, right? I mean, this much portion is for your timer 0, this much portion, sorry, this much is for timer 1, this much is for timer 0. If we are using timer 0, we are in which mode? Tell me.
So mode 1, so 16-bit timer.
Right, mode 1. And if our timer is 1, then we are in which mode?
So 0.
Exactly right. In both the cases, what is the value of get?
0, sir.
0.
0. That means the information we get is we will use the software approach. And what is C by T in both the cases?
0 also.
0. That means they will act as timer and not as counter. So these are the information that we get from the tmod register. Is it clear to all of you?
So the timer
No,
is
sir.
zero.
From where I am getting the mode?
From where you are getting the, see your previous class note, see the tmod register. If you have your previous class note, see the tmod register. Or if you have your book, go to figure 9.3. Make sure all of you understand this up to this.
I understood.
So I believe all of you understood. So we have completed this step. That is load tmod register with the desired value. Next, load initial values to TL and TH. So we are using timer 0 definitely. So we can forget about timer 1. Definitely we are using timer 0. Okay. If we are using timer 0 and this is your set timer 0, so we know that this is your TH0 and this is your TL0. I mean, this is the higher byte, this is the lower byte. So what is the value in lower byte? It is 0F2H. And what is the value in higher byte? 0FFH. So if that is the case, what is the value in timer 0 16-bit register? What is the value? Combine your TH0 and TL0 and tell me what is the number which is there in timer 0.
F2.
F2H, right?
Yes.
So this is the number, or this is the hexadecimal number which is stored in timer 0. Is it clear up to this? There is one question, from where did we get these numbers, or why did we use specifically this number? This is our next topic. For the time being, just assume we got this number randomly or from something. Okay, we have this number. Let's leave it like that. But once you have these two, this is the number that is being generated. Is it understood up to this?
Yes, sir.
So this one is done. Our next task is to start the timer. Okay. Before that, we have got one line, that's complement P 1.5. Okay. Assume this is your microcontroller MUSI. Okay. And this is the pin. So what is the output? Say initially output was 0, so we complement, so it goes high. Okay, assume it goes high. All right. Then we call the delay. Fine. What is set bit TRO? Can anyone tell me what is set bit TRO? What is the function of this one?
Sir, in order to start the timer.
Exactly, in order to start the timer, and that is our third step, start the timer. So how do we start the timer? We start the timer with this line, that is set bit TRO. Why this function will work? Because we see gate is equal to 0. So we know that this instruction will start timer 0. So there is no problem with that. Our timer 0 started. All right. So we start timer 0. What is our next step? Keep monitoring the overflow flag and go out of the loop when TF is equal to 1. So what is actually happening? See, when you start the timer, all right, your timer will start from FFF2. So when you start the timer, you have FFF2. From here, you will go to FFF3. Then from here all the way, you will go to FFFF. Okay, that is the last number. I mean, this is the largest number that you can hold in your timer, isn't it? Right? Come on, respond. At least respond. Let me know.
Yes, sir.
Yes, sir.
Okay, sir. See,
Yes,
in
sir.
all this stage, your overflow flag, which is TF0, will remain 0. But when you have completed here, from here you will go to 0, 0, 0, 0. That means you will go at the beginning. When you reach that stage, in this situation, when you jump from FFFF to 0, 0, 0, 0, your TF0 becomes 1. This is the function of your timer overflow flag from the TCON register. Okay, it checks that whether you have completed the timer or not, whether the timer operation is complete or not. So whenever you roll over from FFFF to 0, this one, your TF0 becomes 1. So that's why this step says keep monitoring the overflow flag and go out of the loop when TF is equal to 1. So how do you do that? We use this one, jump not bit TF0. That means as long as in this bit position there is no bit, that means there is 0, we keep on jumping to this again loop. Once this one TF0 or this bit becomes 1, then we come out of this loop and we go to this line. Is it clear to all of you what just happened? Have you understood?
So there is no increase command here.
No. That is your main advantage of your timer. See, once you write set bit TR0, you are starting your timer. The moment you start your timer, it means that you start counting. Okay. Clear everyone up to this?
Sir, why are we actually in this loop? What
Why?
is happening in this loop?
This
We are
loop,
just wasting time.
yeah, this loop you are checking that whether you have created or whether you have completed your timer operation or not. Definitely the purpose of this portion is to create some time delay, right? How much time delay will be created will depend on these two values. So based on these values, this is how your timer works. It will start from this value. It will roll all the way to FFFF. Then when it rolls over to 0, we understand that desired delay has been reached. So your overflow becomes 1, telling the MUSI that the timer has completed its operation. Then your target is you have to come out of the loop. Then you have to stop the timer and clear the timer flag. That's what we do. We clear the timer 0 and clear the timer flag. We know that this instruction will stop the timer. Clear TR0 will stop the timer. So we'll stop the timer and we clear the timer flag. Then we go to return. That means we come to here, short jump here. Again, we come over here. We load the TL0, TH0 again with this value. So what happens? See, when you complement it, it was high for some time. Then again, when you come over here, you complement it. That means it goes low. So it is having equal upper and lower pulses, and this process will go on. Okay, so this was your 1.54, 1.5. Now let me know.
Can you explain again, sir?
Which
Upper and lower pulse, sir.
Oh, okay. So say your port 1.5 was 0. In this line, you complement it, so it goes high. Then it enters the delay loop, right? So it will come over here, it will complete all this cycle. Again, it will come over here. And when you come over here, you complement it. So it goes low. Then again, you perform all this operation. Again, you come over here. Again, you complement. So it goes high. So isn't it having equal upper and lower portion?
Why was it high in the first place?
This is just assumption. If initially it had low, it started from 0,
Okay,
then
sir. I
complementing
understood,
it,
sir.
it will go to high. Okay. Okay. Any other question? All right. So we have, oh, the last step was reload and repeat. So we reloaded and repeated. Okay. So the next question is, now we automatically go to example 9.5. Okay. This one will cover a lot of examples. All right. Now we are in 9.5. Now the question is, how much is the time delay that we generated in this delay subroutine? Okay, the question is, how much delay did we generate? All right, when the question is like this, we need to have a few information like what is the connected frequency. So say the connected frequency is 11.0592 megahertz. So if this is the frequency, can anyone tell me what is the time period for one machine cycle?
1.085 microsecond.
Right, 1.085 microsecond. All right. So all we need to do now is we need to know for this time, for these values, how many cycles did the MUSI execute? Okay. So how can you do that? See, it started from FFF2 and it stopped where? Tell me. Where did it stop? FFFF, right? So in order to find the cycle, what we can do, we can write FFFF minus FFF2, that is this number. So how much do you get? What is the result? Tell me.
14.
0D.
0DH. If you convert it to decimal, how much do you get?
So 18.
Huh?
18. Sir. Oh, sorry, sir. 13. 13.
All right. So if I say that because of loading these numbers, we had total 13 machine cycles. Am I correct or not? Is it a correct information?
Probably not, sir.
Okay.
No,
Why
sir.
not? Why not?
Sir, after FFFF, it will go another one machine cycle 0000.
Exactly. After FFF, it will go another machine cycle, then it will stop. Therefore, your total machine cycle is equal to 13 plus 1, which makes it 14D. That means you have total 14 machine cycle. Is it clear up to this that we had total 14 machine cycle?
Yes, sir.
Okay. So what is the delay generated? So delay will be simply 14 into 1.085 microsecond. How much do you get? Come on, if you multiply this, how much do you get?
Sir, 15.19 microsecond.
Right, 15.19 microsecond. All right. If this is the delay, tell me what
Why
is.
why did we add 1?
Okay, why did we
There
add
was
1?
13.
See, we started from FFF2, right? When did
Yes,
we
sir.
stop? Did we stop at FFF or we stopped at 0000?
0000.
Exactly. We stopped at 0000, right? But when we are subtracting from FFFF. So don't we have to add another extra 1 over here? Because another machine cycle was taken to go from here to here, right?
Yes, sir. I understood.
So if this is the delay, tell me what is the time period of the generated signal, of this signal. What is the time period? What is the time period of this signal?
Sir, 30.38 microsecond.
I mean, how do we get it? We multiply 2
Howl
into
of
15.19 microsecond. So how much we get? 30.38 microsecond. So those who are having understanding this difference, let me say, this portion is your delay, and this portion is your time period. Okay, this is how we calculate time period and delay. All right, so the last question. What is the frequency of the signal that you generated in port 1.5? How do you find that? How do you find the frequency that is generated on this particular pin? Or
1 divided by time period.
right, 1 by time period. So 1 by 30.38 microsecond. Whatever you get, that is the answer. So see how many things we found out. We found out the amount of delay that is being generated. We found out the time period of the generated signal. We found out the frequency of the generated signal. So if the only thing we don't know still now is to generate a specific time period, how much should be loaded over here? That some of you might already start guessing, but still I will discuss it. Okay, that is the only thing that is left. But apart from that, if any of you have any question over here, please ask. Please do ask if you have any question over here.
Sir, will there be any question with this with custom duty cycle? This is 50%. What if you're told to change the duty cycle also? Will this
Of course,
code
it might be there. Of course, that question might be there. And this was there in chapter 4, I guess.
Yes, sir. In there we used in the normal delay, not the time.
Yeah. So what? You got the concept over there. The concept is there.
Okay, sir.
Right? It will still be there. Anyway, but if you still worried about this custom duty cycle, I'll suggest you something. See the class lecture of section A, today's class. Okay. Try to see the recording of their one. Because
Okay,
they also had some question, and today actually I had a lot of time in section A. So I could discuss all of those things, but if I start discussing over here, I mean, I'll not be able to finish it. Okay, so sorry
Okay.
for that, but it is not a big issue. You see their class recording. Still, if you face any difficulty, I will make sure I explain it in your class as well. Okay, but I will ask you go through the recording first of all.
Yes, sir.
All right. Now, so I erase this portion. So how did we find the delay? That is what I was discussing, right? So one of the ways of finding the delay is this one. We will go for FF, then we will minus this value as we did FF2. Then we will add an additional 1. Then the answer that we got was 0EH. If we convert that, we got 14 decimal. That means we had total 14 machine cycles. So finally, to find out the exact delay, we multiplied 14 with 1.085 microsecond and we got our answer. There is another way. Of course, very similar, nothing different. Help me someone, okay, with this one. There is another way. This one is A. The first thing you have to do is convert FF2 into decimal. So if this is the hexadecimal form, what is the decimal form of FF2? Come on, just tell me the answer. How much is the hexadecimal? So decimal equivalent of this?
So
65522.
This one?
Yes, sir.
All right. So the next step is very simple. You subtract these numbers from 65536, not 35. Okay, 36 because we have got an additional 1. So that's why you have added this 1 over here. Subtract this from 65522. The result you get is definitely 14. So finally, delay will be 14 into 1.085. I mean, it is very obvious, but still I have to discuss it for the next question. So these are the two ways by which you can generate the delay. You can either do the calculation in hexa, then convert that to decimal, or you can initially convert that to decimal, then perform the operation. So are these two ways clear? Up to this, is it clear to all of you? Yes, no,
Yes, sir.
maybe. Okay, so you understood, right? So the next thing that we need to discuss is how can we find the specific values? All right. So let me explain all this with an example. Okay. So I hope you have finished writing. All right. Say the question is the connected crystal is 11.0592 megahertz, and what you have to do is we need to create a time delay of 5 milliseconds on port P2.3. A very simple question. The only thing is we need to create a delay of 5 milliseconds. So let's see the solution. So what is the first step? Divide the desired time delay by 1.085 microsecond. So according to the first step, my time delay is 5 milliseconds. So 5 milliseconds should be divided by 1.085 microsecond. How much do we get if we perform this division? How much do we get?
So 4608.29.
Yeah, so you can either round it and get 4608 or you can have 4609 also, doesn't matter. Okay, it's the same thing. Now, so we have completed this first step. Then perform 65536 minus n. All right. According to the next step, what we need to do, 65536 minus n is 4608. Okay, if that is the case, how much do we get after this subtraction?
So 60928.
Right, 60928. Then convert the result of step 2 into hex. Okay, so if I convert this into hex, how much do I get?
So double E double zero.
Right, 0008. So we have already got. So what will be there in TL and what will be there in TH?
So TH are double E and TL double zero.
Right, TL will be 00, TH will be. So fine. So see here if we know the value or which is to be loaded in TL and TH, rest of the code is very simple. Okay, so let me just write the code which is also given in your book. So initially we clear this port. Of course, we need to load some value in P mode. We need to specify which timer and which mode. So let's keep it simple. That's it. This is the code. If there is any confusion in this code, you can always ask. So see the code and let me know whether you have any confusion or not. All right. So since this one is very obvious, let's twist the question a little bit. Say if the question was generate a frequency of 100 kilohertz. Say this was the question. Okay. The question was generate a frequency of 100 kilohertz. Then what will be the value in TL and TH? Can anyone tell me? Or tell me the steps. What should we do? What is the first thing that we have to do? If the question is generate a frequency of 100 kilohertz, then what is the first thing that we have to do?
Sir, convert it into time period.
Yeah. So for 100 kilohertz, what is the time period? Tell me. It is 1 over frequency, right? So if 1 over frequency, how much do you get?
Sir, 1 into 10 to the minus 5.
So I can write 10 microseconds, right?
Yes, sir.
So we have found out the time period. So should this be the delay? What should be the next step?
Divide by 2.
Right. Very good. Then we need to divide it by 2. Okay. So 10 microsecond divided by 2 is 5 microsecond. The rest of the thing is like this. You divide in step C, 5 microsecond will be divided by 1.085 microsecond, and then you will convert and so on. You get the idea, right? Is it clear up to this?
Sir, in the code, why are we setting set bit P2.3?
Oh,
What is happening there?
this is nothing. This is, I mean, the target was I have to create a 5 millisecond pulse in P2.3. Okay. So 5 millisecond pulse means it will remain low, then it will go high. It will remain high for 5 milliseconds, then again it will go low. So that's why we cleared it first, then we generated a delay of 5 milliseconds, then again we cleared it and it came down. That's it. This is the output that we wanted. Okay. Have you understood?
No, sir.
Which portion did you not understand? Tell me. I mean, the question was, if I had written the entire question, you would have understood. The question was create a pulse width of 5 milliseconds. Okay, I have to create a pulse width of 5 milliseconds. Pulse means it will remain low, suddenly it will go high. Okay, when it goes high, that is known as a pulse. So how much should be the duration of that pulse? The pulse should remain high for 5 milliseconds. So it will remain low, suddenly it will go up, it will remain high, the pulse will remain high for 5 milliseconds, then again it will come low and it will go up.
Okay, sir, I understood.
Okay. So is this portion of frequency understood all of you? All right. If you don't respond, I will assume you have understood. Now say, one last twist. Say the connected crystal is 22 megahertz and we need to generate 100 kilohertz. Now, if this is the question, we have got a lot of steps, A, B, C, D, E, F, all these steps, right? So in which step will there be a change? In this step, in which step will there be a change?
Let's see.
Right. In step C, instead of 1.085 microsecond, you have to use the machine cycle duration of this 22 megahertz, which if you calculate, I think will come as 0.546 microsecond. And all of you should be able to find out how I got this one. So is it clear up to this? Yes, no, something. Tell me whether you understood up to this or not.
Yes, sir.
Yes, sir.
Okay, so I still have got some time. So let me show you the question that was asked. If there is a what? If duty cycle is customized. Let me show you. Just a second. All of you, can you see my screen? Can you see
Yes,
the
sir.
screen? All right. Yes, sir. See the code. Okay. And tell me what is the duty cycle over here. Let's see. Tell me how much is the duty cycle. Go through the code. Take your time. I don't have any problem. Take your time. See this example. Take your time and tell me what is the how much is the duty cycle.
Sir, 66%.
Right. The duty cycle is 66%. Everyone, please go through this code. If there is anything that you face difficulty in understanding, let me know. This was the example that I discussed. Okay, this example again, this example is not given in your book. Okay, so if you want, you can take, you can write it down or you can take a screenshot from here. But this example is not there in your book. This one is generating 66%, 66.6% duty cycle using timers. The delay is also calculated on the right hand side, as you can see in both the ways. So you can follow anyway. The created delay is 19.93 milliseconds, I guess. Yeah. And also you should understand that this portion is the high portion, which will be twice of this low portion. The figure has been also drawn in that same way. So if there is anything from here you want to ask, you can ask. কে জানি কোশ্চেন করছিল, এখন বুঝছো কিভাবে করবা কাস্টমাইজ ডিউটি সাইকেল?
Yes, sir. Got it.
All right, then tell me something from here. Now if I ask you what is the time period, how will you calculate the time period? Will you multiply the delay with 2? Will it be 19.93 millisecond into 2?
No, sir.
Then what will be the time period?
3 into 19.9.
Right, the time period will be 3 into 19.931. All of you must have a clear concept about all these things. Just coding is not enough. Okay, you need to know about all these things, otherwise it will be difficult for you. Right, so yeah, I think I will stop here today. How was your quiz, by the way? Last class, how was your quiz?
Sir, it was not good, sir.
Okay, now it was not good as in it was difficult or it was easy but my preparation was not sufficient? Which one?
Sir, a little bit difficult.
তোমাদের কোন কোশ্চেনটা ছিল?
Sir, ABCD code convert করা আর হচ্ছে
3 লাইনের কোড. It is your answer is just 3 or 4 line code, I think. Just the masking was there. What else? And rotate RRC, I think. Those were the only 2 things you had to do. For sending out in series, it had to be RRC, and for masking to EBCDIC, you had just to know the masking. So what was our target? I have to make sure that my upper byte is 1 and my lower byte is preserved. So how can we do that? I can do that in a number of ways. You can use OR operation and make the upper byte of your OR operation as 1 1 1 1 and the lower byte as 0 0 0 0. So that will make your upper byte as 1 1 1 1 and lower byte will be preserved. That's it. Why do you think it was difficult? It was not at all difficult.
Sir, the first portion, sir.
First
The
portion
first
code,
portion of the
sending out in series.
জি স্যার প্যারালাল থেকে সিরিজে নেওয়াটা
Yes, sir.
Parallel means what? You are taking all the 8 bits at once, right? Then you have to just send out in series. So you will use RRC, and every time you will send the value of carry to the port from where you want to send it. That's it. Just write RRC, then A, and then move P2 point whatever port is given, comma C. That's it, finished, done, nothing else. RRC or RRL, it will depend whether LSB goes out first or MSB goes out first. So based on that, you have to use either RRC or RLC. That's it. That is the only difference. Rotate right or rotate left. That is only thing. Your one was the easiest, I think. Your quiz was the smallest one, and you got the maximum time, 20 minutes. It is 3 or 4 line code, nothing else. All right, let me take your attendance before that. Section B. I can see 4 of you are absent. Can you just tell me who are those 4? Let me help you. 16 batch 147. Are you present? 16 series 147. So no. So I already got one of you. Tell me who are the rest 3. Just look for your corresponding ID. and see if he or she is present or absent.
Sir, I think 74.
74. So 74, are you present? Okay, so 74 is not present. We have got 2. We need another 2.
Sir, I think maybe 55.
I can always check. 055, right? Yeah,
Yes, sir.
055 is absent. 055. Where is 055? 055. Mohibur আছে। ওদের কি ভালোই absent থাকে। আচ্ছা। And who is the last one? The last one, who is the last one who is absent? Suddenly the participant number increased. Now the number you have, according to this number, only 2. Okay, anyway. So rest of you are present. If any one of you have any question, you can stay back. The others are free to leave. Thank you. Oh, CR একটু থাকলে ভালো। কে জানি CR জানি কে?
Yes, sir.
সাদমান।
Yes, sir.
আচ্ছা, আমাদের কালকে একটা এক্সট্রা ক্লাস হওয়ার কথা না?
Ji, sir.